Okay, I'm going to add and subtract fractions. Order of operations says that you must use PEMDAS or parentheses first, and so I'll write that down very, very quickly. That the order of operations is parentheses first, followed by exponents. Multiplication and division have equal priority, and so do subtraction and addition. Always multiply or divide from left to right, and add or subtract from left to right. So I've got my set of parentheses, so I'd like to add those quantities, 1/3 plus 1/4. I don't have a common denominator, so the denominator 3 and 4 can be made common by looking at a couple of facts. 3 times 4 is 12, and 4 times 3 is 12. And 12 is also the denominator of 11/12. So 12 would be the common denominator for all three fractions. So 4, got to multiply that by 3. The rule is that to keep the fraction equivalent, we must multiply the numerator by 3. And 1/3, let's multiply that by 4. And again, to keep it equivalent, we multiply the numerator by 4. So after rewriting this, we end up with 11 over 12 minus quantity. I'm going to use brackets instead of parentheses. 4 over 12 plus 3 over 12. So the order of operations again says to work within your parentheses first, and 4 plus 3 is 12. Now I want to verify that when you add 4 and 3, I can do that mentally, but if I were to show every single step, it would be written this way. 11 over 12 minus, this would be 4 plus 3 over 12. And that's the idea behind finding the common denominator, is that your individual denominators merge together to form one fraction with a denominator of 12. 4 plus 3 is 7. So now we have 11 over 12 minus 7/12. Again, I want to make sure that you know that it's easy to add 4 plus 3 to get 7. So this middle step is just me explaining the details of that step. Now, again, I'll show the work. We're adding 11, we're subtracting 11 and 7. So 11 minus 7 over 12. And again, I know that it can be done mentally at this step. But 11 minus 7 is 4. And so my answer is 4 over 12. Reducing, when you reduce, again, you must reduce both denominator and numerator by the same value. Otherwise, it's not equivalent. To keep the fraction equivalent, you must do that. We're going to put 1 over 3. So the answer is A. Number 6, which of the following numerical expressions results in a negative number? So here are the rules for adding integers. When you add numbers that have the same sign, you keep the sign. So here's an example. If I have a negative number plus another negative number, the answer is going to be negative. Again, this is not a negative multiplied by a negative. This is negative plus a negative. You end up with a negative answer. If you have a positive number and you're adding another positive number, your answer stays positive. Okay? Now, when you add numbers that have different signs, the rules are different. And how that works is you actually take the two numbers and you take the larger absolute value of the numbers listed, subtract them, and then you keep the sign of the number with the largest absolute value. So here's an example of this one. I'll give you an example. So let's say I have -5 plus 7. Okay. So looking at these two numbers, if I take the absolute value of negative 5, it becomes positive. And I should say 7. Like the absolute value of 7 is 7. So 7 and 5, let's subtract those. Let's find the difference. So 7 minus 5 is 2. Okay, so you're taking these two numbers and just subtracting them when the signs are different. And so we end up with 2. Now, is it negative 2 or positive 2? That's the question. And the answer would be positive 2. And the reason why is because when you look at negative 5 and 7, which is larger, 5 or 7? You would say 7. And 7 is a positive number, so the positive sign dominates. It becomes a positive answer. Okay? Now if I was to switch that up, write it this way, this would be, say if it was positive 5 plus negative 7. So again, you still subtract 7 minus 5, right? But the answer is not positive 2. And here's why. Again, when you look at 5 and 7, ignoring the negative sign, because that's what I mean when I say the absolute value of a number. The 7 is a larger absolute value than 5. 7 is larger. 7 has a negative sign. So that carries over with the answer. There's also a technique called using integer tiles, which is a very excellent technique. And the way that technique works is, if you look at 5, it's a positive number, so you write 5 positive signs that represent positive 5. And then 7, that would be 7 negative signs. Okay? And what you do is you pair up, you're combining, you add them together. You pair up your negative signs with your positive signs. Now, what occurs there is a negative and a positive are opposite to each other, so they cancel each other. They become 0. And so what's left here? 2 negatives, right? And 2 negatives represent negative 2. So that's another way of working this out, okay? Using algebra tiles. So that's a long explanation before I actually work out the problem. So by looking at this, again, it says which expression results in a negative number. So you have a negative plus a negative. Okay, the signs are the same. You're adding them. They're both negative. So this would have to be a negative answer, guys. It'd be negative 10. Here, 7 is larger than 3. When you subtract, you would get 7 minus 3 is 4. Be a positive answer. 3 and 7 both are positive, right? So it's positive 10. And of course here, there would be multiple steps, and after working this out, it would still be a positive answer, and it looks like it's going to be, let's see, negative 4, 6, 7. Yeah, 7. Okay? And so the only answer that's, the only expression that results in a negative answer is A. Okay, next question. 100 is multiplied by a number between 0 and 1. The answer has to be what? Okay, so let's look at 100. Okay. So, looking at 100, it says it must be multiplied by a number that's between 0 and 1. So if I were to take 100, and let's say I wanted to make it exactly 1, I could multiply it by 1 over 100. And the answer would be 1. Remember that old rule? Because this would be answer is 1. And so it's like the answer could be 1, right? Okay. What if I multiplied 100 by 1,000? What would that be? Just add a 0 here. So we'd end up with a different kind of number here. we'd end up with 1 over 1,000, so cross out these zeros and we'd end up with 1 over 10. And 1 over 10 is smaller than 1. Okay? And so if I multiply by 10,000, it would be 1 over 100. And so it looks like this is getting closer and closer to 0. Okay. Now, if I multiplied 100 by, let's say, 99 over 100. Not 1 yet, because 100 over 100 is 1. Close to 1. And what I end up with is 99. Okay? That's pretty darn close to 100, isn't it? So I got to 99. So what I'm thinking here is that my number is going to be between 0 and 100. And what I used was a guess and check technique. A little different, but the reason why I'm able to do that is because I know what it means to be a number between 0 and 1. And numbers that are close to 0 have large denominators. So here are some examples. So numbers close to 0 would be like 1 over 10 is 0.1. Just put a 0 there. And I can see that 1 over 100 becomes 0.01. 1 over 1,000, 0.001. And so you see how these values can be written so that the number of zeros is totally dependent on how large my denominator is. I can make that as large as I want. And so these values can get really, really close to zeros. So, and when you multiply 100 by these values, 100 becomes closer and closer to 0. Now 1, fractions that look like 1, well, let's see, a half would be something like, let's say, 5 over 10. That's a half, or 0.5. And then if I say 6 over 10, that's 0.6. See that? 7 over 10, that's 0.7. And then, of course, about 9 over 10, that's 0.9. So these are getting closer and closer to 1. And so I can get extremely close by maybe changing this. I can say that it would be 99 over 100. That would be 0.99. So I'm getting closer and closer to 1. That means that when you multiply 100 by a number that's very close to 1, you're getting closer and closer to 100, as close as you want. And that being said, you can see that your values are going to be between 0 and 100. Next question. It says John uses 2/3 of a cup of oats per serving to make oatmeal. How many cups of oats does he need to make 6 servings? Okay, 2/3 of a cup of oats per serving. That is the key word. What does it mean to serve someone oatmeal? Literally, it means you take 1 bowl of oatmeal and serve it to 1 person. Well, how do you make that 1 bowl of oatmeal? You have to have the ingredients, like water and the oatmeal. Well, how much oatmeal do you put in the bowl to make that bowl? You put something called a cup. How much of a cup? 2/3 of a cup. So 1 bowl of oatmeal is made by using 2/3 cup of oats. This makes 1 bowl. But now I want to make 6 servings. That means I'm feeding these oats to 6 individual people. I would need 6 bowls, right? And so how many cups of oats would I need? That's the idea, right? So I don't know how many oats I need to make 1, not 6, right? Well, you just think about it. You're just going to take 2/3 and multiply it 6 times, right? Multiply it by 6. And that would create your 6 other servings. Now, you might think that you can add 2/3 6 times. That's also a way. You can take 2/3 and add it 6 times if you'd like, right? Do this 6 times. But I'm going to use a shortcut. I don't want to use this technique. Repeated addition is multiplication. So shortcut that would be just 2/3 multiplied by 6, which is 2/3 multiplied by 6/1. I'm going to cross reduce. So 2 times 2 is 4. 1 times 1 is 1. The answer is 4 cups. So in order to make 6 servings, I need 4 cups. What is the value of 1/8 to the 2nd power? Okay, now, so by definition, what an exponent does is it causes the base to repeatedly multiply. So if I wrote x to the 4th, that just means it's x times x times x times x. You notice that you see 4 x's, right? And that's because the exponent is 4. And so when you have an expression like 1/8, it's still the same situation. It's a fraction. And what you're doing is you're going to write it repeatedly 2 times. So you are multiplying 1/8 twice. That just means 1 times 1 over 8 times 8, which is 1 over 64. Okay? And again, that 2 right? Okay, last question here. If Freya makes 4 of her 5 free throws in a basketball game, what is her free throw shooting percentage? All right, so 4 of her 5 free throws. So let's give a quick explanation of what a fraction is generally. The most, I guess the most frequently used definition is something that I saw in primary school, first, second, third, fourth, fifth grade. I saw that a fraction was a part of a whole. Okay, and so I had seen that written many times. And so when I look at these numbers, the whole number would be 5 because that represents all of the free throws that I shot, right? And the part, or the number of free throws made from those 5 was 4, right? So it'd be 4 over 5 would be a fraction, 4 over 5 free throws. And so that's the first definition. When you're given a comparison of 2 numbers, generally you write them as a ratio. And from there you can make a percent. And so we talked about this. How do you convert a fraction to a percent? Well, one way is to change the fraction to a decimal and then convert the decimal to a percent. So that's the technique I'll use here. So 4 over 5, how is that written as a fraction? Or, excuse me, a decimal. So it's 5 goes into 4, 0 times. So we've got to continue the division process. And so I add a 0. I brought that decimal up. Does 5 go into 40? Yes, 8 times. 8 times 5 is 40. Remainder 0. So as a decimal, that's your answer. So converting a decimal to a percentage is straightforward. You move your decimal point 2 spots to the right. It's always 2 spots. And if there is a blank spot, you fill it with a 0. So I end up with, now, I end up with that. I want to make a comment about this. The 0 to the left of 8, you don't need it. It's not necessary. You can have a 0 to the right of the decimal, but that's not even necessary. Just wanted to show you where it was at after I moved it. Okay. So my answer is 80%. Okay? I hope you enjoyed the video. Hope it helps. And remember, study hard and learn a lot. See you later.